Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello, and welcome to another episode of the GOTO Book Club. I am Mark Rendle. I'm joined today by Tomasz Lelek. I will let Tomasz introduce himself and say a little bit about himself.
Hi, welcome everyone. So I'm Tomasz. So I am author of this Software Mistakes and Tradeoffs book. We'll be talking about the book today. Also, I'm a software engineer, working more than 10 years in the industry. So currently I'm working at Dremio company. So we are building data lakehouse solution. Previously I was working on data stacks, but we were building Cassandra and products around Cassandra database. So in my book I was trying to share the experiences from data stacks and previews, because I wasn't working at Dremio when the book was finished. And before that, I was also working at Allegro Group. That's the e-commerce in Poland. The biggest company. For example, Amazon and eBay wanted to get this market, but it was too hard because Allegro is well known here. Everyone uses it. So there is 15 million of active users. So I was involved in streaming, processing, and other interesting stuff there. Also, I've covered part of it in the book. So that's me.
Okay. And just to introduce me, Mark Rendle, software engineer, 34 years now. So when I started, we were dumb terminals attached to SCSI Unix machines and C and Infomix, and over the course of those 34 years, I have seen a lot of software mistakes and trade-offs. And I think I got roped into this because of my Programming's Greatest Mistakes talk, which is, NASA exploding things on the way to Mars and proper big mistakes, not just choosing the wrong front-end library or something like that. I am very interested in the kind of the higher level aspects of software development and engineering. And this book I found extremely interesting, and I think it's an interesting angle. It's not one that I've seen before. So was there a moment when you thought, I should write a book about this?
Yeah, so the story is that I was trying to document all the decisions and mistakes as well that I did or the team that I was participated in did in past. So when we were working on some problems and there was some decision involved, and almost always there is some decision involved. So if you want to go into one path or another path in the code or architecture or or even the library that you are choosing, then I was trying to document what was the main factors that backed up this decision and why we go and pick option 1 or 2 or etc. And I had the list of such decisions and mistakes. And then I was after a year or two, when the system was live in production, I was trying to do some retrospective and see if it was the best decision that we can make. And often it was not the best one, but because there are trade-offs, right? So then I was trying to understand the trade-offs and to see if you would pick a different solution, would it be better or not, right? So I was like trying to document such like the biggest things that also were repeating in the ecosystem that I was working in. So I had the list and it was like 10 items or even more at some time. And at this moment, I started to think that maybe I can document that in a better way, for other people, to like benefit from it. So like the one option would be to just have a blog post, right? With not related topics. But yeah, they're more like end-to-end approach that could be distributed better is write a book. So that was the idea.
Yeah. And like I say, it's a very good book, and there's a lot of interesting stuff in there. It's not one of the things I like about it. You've got some code samples, and they could be Java, they could be C#, but it's applicable no matter what language you're programming in, whether you're front end, back end, DevOps, wherever you are. A lot of the ideas and concepts in the book they're very broadly applicable.
Mm-hmm. I was trying to like back up every chapter with actual code and tests as well.
Yes.
So I think GitHub repository is public, so you can check it out. It's on my GitHub, or you can just type the title of the book and GitHub in Google, right? So each code example is paired with tests. So unit tests, integration tests, and so on. So you can also experiment and break stuff.
That book title again, just in case anybody missed it, is Software Mistakes and Tradeoffs by Tomasz Lelek and John Skeet. What was it like working with John on the book?
Yeah, so he was involved in the book at the early stage. So when I sent the idea for the book to the Manning publisher, Manning is sending this to top best-selling authors of this publisher. John was one of them. So he liked the idea of the book a lot, and he was he proposed that he could contribute to a couple of chapters that he has most experience in. So if you will find this chapter about data.
So working effectively with date and time data was the one that jumped out at me when I knew John was working on it, because obviously he maintains the NodaTime library for .NET, which is essentially a .NET port of YodaTime from Java. And I have watched a 1-hour talk by John on why dates and times are difficult. And yeah, it's an insanely complicated.
Yeah, so he is able to elaborate more about this topic in this chapter. So you'll find really interesting stuff there. When I was reading it as well, it was very entertaining read as well, because he's trying to consider time zones between planets, for example. So what will happen if we need to communicate between Mars and Earth? The second chapter that he was also volunteering to help was about compatibility of data, so managing versioning and so on. Because he's also deeply involved in protobuf format at Google. You have in the industry of storing data, you have Avro format, Apache Avro, that also allows you to keep consistent, keep compatibility of your data, evolve it, and so on. You have also Parquet, that is more optimized for fast queries, columnar storage. Also, you have Protobuf, that is more generic format that allows you also to, gRPC is backed up by Proto. So it allows you to define like APIs of your application in a very strict schema way. So that's why he volunteered, and also he authored this chapter. I mean, my first idea was to use Avro as the format for like explaining concepts there, because I have more experience in Avro. I was working a lot with Apache Kafka, that treats Avro as the main format for some good reasons. But of course, John's knowledge about this topic was even wider. So we changed to protobuf, but this is also only for demonstrating the concepts, right? Because concepts are the same, like keeping backward compatibility, forward compatibility, avoiding your API, allowing your API to like not break when you change stuff, right? How to version it and so on.
And the people who designed protobuf, this was one of their kind of key considerations in the original design, was that you can add new fields to objects without breaking the existing contract. And with gRPC, which is the RPC framework that runs on top of protobuf and uses protobuf as its wire format.
It's also interesting for me too, because this gRPC adoption is trending a lot around now. Like when this book was completed, gRPC was like not yet the recommended way to create APIs between services, because it's mostly used in microservices world. When you have a lot of services, you need contracts and so on. So previously, like people tend to use REST, right, for it, or GraphQL. Yeah. But now I see that gRPC is trending a lot. So I think this chapter is even more relevant now than it was when it was like finished.
Yeah. Which is always nice. Because I learned about gRPC. It was one of those things I was kind of aware that it existed, but Microsoft, I'm a .NET guy mainly. And I've been working with Microsoft's tech 25 years, and they deprecated WCF, which was their RPC framework from like 2005, and then recommended gRPC as the alternative, and they've invested very heavily in making sure that .NET's gRPC implementation is absolutely it's one of the fastest out there, and it's very easy to work with.
Also, it's important that those formats are like technology agnostic, right? So you can, and also those patterns for compatibility, like you can use it from C# as you said, from Java or any other language.
And with gRPC, it is almost every other language. I don't think Zig supports gRPC yet, but you can certainly do it in Rust and Go. So yeah.
I mean, there was always, like, in our industry, I think there was always, endeavors to try to create formats that are the way to encapsulate communication, right, between services. There were some, high-level frameworks that were hiding remote calls, that I think is not a good idea, because you need to be aware that remote calls involve, potential failures. Sometimes you need to retry, idempotency, and so on. So I think that's a good middle ground between those two things.
Yes, there is a tendency with RPC frameworks to pretend that they're not RPC frameworks, and to try and make it look like everything's happening in one place. And you do need to remember that you could have network partitions, or services could be in the middle of a rolling upgrade, or all sorts of things could be going on.
This chapter is related also to other chapters in my book, like delivery semantics. So if you have good format like RPC, gRPC, protobuf, and so on, and you can build on top of it, like build system that works, for example, at least once, guarantee. That allows you to, always deliver your messages. But in that case, you need to consider a lot of things like side effects, like this idempotency of your API. So also in this chapter, I'm like trying to consider a situation when how to design APIs that are idempotent, that may not be idempotent at the first site, right? For example, if you have event-based system, you can like send only like modification. Like for example, you have an entity with a lot of fields, and you can in the event you can set only the notification with one field that changed, but that's problematic because if you retry that, you don't know if this modification was done twice or not, right? So the better approach is like to send the whole entity. It allows you to retry with some like unique identifier, right?
Yes. Yeah. E-tags and things of that nature.
Mm-hmm.
Looking at some of the other chapters in the book, and actually chapter 2 was one of my favorite. Code duplication is not always bad. And I've actually seen discussion of this over the last sort of week or so, particularly with reference to React and React components and actually that whole component-based way of building front ends and user interfaces. And there is a tendency, this concept of dry, don't repeat yourself, which I think came from the pragmatic programmer. And it's a good kind of idea. It's a good notion to bear in mind. But you do see people saying, "Oh, I've written essentially the same 4 lines of code twice. I should pull that out into a helper method and put it in a helper project and that sort of thing." And there is that tendency to try and abstract and extract functionality when it doesn't necessarily need to be extracted. And then particularly you get to this point where you then start trying to build flexibility into your new abstraction layer with configuration points, because actually it's not doing the same thing over and over again. It's doing similar things over and over again. And it was very refreshing to read a book that said, you know what, sometimes it's okay just to have very similar looking code in multiple places in your application. So
yeah, when I was discussing this idea with John, this chapter with John, he said a very nice like quote. So like when you have the code that is similar at the beginning, it doesn't mean that they have the same functionalities. They may business functionalities that may evolve in a different way. And if you have this abstraction, then you are not able to evolve it in a different ways. Or you can, but you will need to build some complex patterns, template patterns, abstractions, and so on.
Yeah.
And also it's like in the context of like hierarchy of your organization as well. So if you have like 2 independent like services that handling different business entities, and you have this common code refactored to a common component, so then you have this like point of like contention between those 2 or more teams. So if you want to change something, you cannot change or evolve so fast, right? I mean, that can be important in the startup context. So if you want to deliver something quickly, then you have this, like if you are in the static languages world, when you need to compile things, then you need to have maybe some kind of a library that needs to be distributed, and you need to upgrade your services. I mean, there's a lot of aspects around that. And I agree as well that this principle is like accurate in most of the cases. Because when you start like programming or you have like first project or, second project, then it's better to like have some guidelines that allows you to write better code. But then you start noticing that it's not always accurate.
Yeah. One thing I've seen a lot as teams are told, we need to do microservices and break things down into smaller services. And you have two services that are talking to each other, maybe using an HTTP JSON API. And so they both need the data transfer objects. They need the classes that are being passed backwards and forwards. And then people can create a NuGet package or a Gradle package or something with those object classes in them, which are then shared between the two or three services that are using them, which I think is an anti-pattern. If your release process involves pushing a new microservice into production that is then live, and also publishing a NuGet package that then people have to update specifically and say, I'm now going to version 2.1 of this NuGet package or whatever, versus just very simply handwriting an object with maybe a dozen properties and having that in both places. And actually I do a gRPC workshop, a 2-day workshop on gRPC. And one of the things I point out there is that with gRPC and with other RPC frameworks as well, and actually with HTTP APIs, if you're using Swagger, you have this kind of text document, so a proto file or an openapi.json or a swagger.json file, which you can distribute, or you can just make it part of your wiki or part of your GitHub repo, and then people generate code using that. And when I'm teaching the workshop, one of the things I point out is that if you're using a proto file and it's got 8 RPC methods in it and 60 message type objects in there, if you're building a service that only needs to call one of them and only needs 5 of those objects, you can delete the rest. And you can only generate the code for even down to removing specific fields, and then your code will just ignore those fields, and it doesn't matter if they're there or not. And so, and this comes back to versioning as well, is if they take away a property that you weren't using, then you don't need to change your code at all. You just go, yep, no, we're not using that. We don't care about it. It's not referenced anywhere.
So when you're consuming your data, you don't need to consume everything.
Yeah, exactly. Which is one of the nice things about GraphQL, because with gRPC and protobuf and with REST and JSON APIs, even if you're not consuming all the properties, it still sends them all over the network because it doesn't know which ones you're reading. Whereas GraphQL, you can actually say, I only want these 3 fields, and it will throw those back. One of the sort of general things that I really liked about this book is a lot of the time you'll buy a book on a new pattern or a new framework or a new paradigm in software engineering, and it's sold as a magic bullet. It's like, this can solve all your problems, whereas your book makes it very clear that there's not a one-size-fits-all solution, that it's not, if you just do this and this and this, and then everything will be smooth. Whereas you're looking at, you could do this, and here's the pros and cons of doing it this way, and you can do it this way, and the factors that go into deciding which are the right choices for your particular, and it's more teaching people how to think and how to analyze the problem, and what factors to bear in mind, rather than saying, here is the solution to your problem. Was that something that you were aiming for?
Yes, that's why my like goal was to write a book that will not go outdated quickly, right? So my idea was, and that ideal scenario was that this book could be like someone will read it in 5 years or more, like even 10 years, and some of the things will be still relevant. That's why also I didn't use a lot of frameworks, right? When showing the code examples and those patterns. So I've tried to use the only standard JDK without adding a lot of additional frameworks. Of course, sometimes it was easier to explain things based on some well-known solution that is used in a lot of places. Like, for example, I was talking a bit about dependency injection, that you can do it yourself. You don't always need a framework that does that for you.
Yeah.
But to demonstrate it, I was showing Google, Guava, I think. Sorry, Juice, or one of the, I don't remember now, one of the frameworks from DI, right? But so having it in the context of the actual real world example, but still proposing a solution that is framework agnostic. So that was my goal for the most of the chapters. And I think the book was published 2 years ago, right? And it's still very relevant. So currently, I think none of the chapters got outdated.
No. So, certainly when I was reading it, it all seemed very current. And like I say, some of it relevant to conversations I've heard in the last couple of weeks. Is there anything that you would add to the book now, after another couple of years of, being in the trenches, working on actual software projects? Anything else you've come across in that time?
Mm-hmm. I mean, maybe I would focus a bit. I mean, there was I had the idea that maybe in the future I will create a second part of it, like software mistakes and trade-offs, after, some years, or part 2. I think I will focus more on the open source and how the open source code evolves, and how it impacts the community. Because when I was working on DataStax, I was part of the Java driver team. So we were working on this Java driver for Cassandra, that is open source framework, and also I was contributing to a couple of frameworks that were firstly private and then transferred to be open source. So this growth from taking the project that was proprietary one, for example, I was leading a Kafka connector framework, Kafka connector from DataStax that allows you to integrate Kafka with Cassandra, and it started as a private project, but then we were transforming it to open source. And this process was quite interesting. Was what bits you need to abstract away, how to make it more common, more generic, so the community can use it. So that will be definitely one topic that I would focus more.
And I've worked on a couple of projects where we had parts of it that were made open source for different reasons. And that process of prepping what has been a closed source in-house, maybe a team of 3 or 4 people working on it, and turning that into something that you can publish on GitHub or GitLab. I mean, in a lot of cases, it's going through and taking out sort of slightly salty comments and function names and variable names and things, but also just getting code into a state where a potential contributor can come along and be able to understand the code and what it's doing and how it's doing it, and be able to contribute, is a challenge. It's a difficult process. I think I would be very interested to read thoughts on that.
Yeah, also like this making project open source is more like about like subtracting, not adding new stuff. So you are like removing parts of the code while like increasing the like adaptability of your code and potential use cases. Also, it's about like providing more extension points to your code. I mean, I briefly touched in this current book about that, how to make it easier for your customers to extend your code, and it's even more tricky in the context of like multi-threaded or asynchronous code, because maybe you may have some assumptions that the code is not non-blocking, and when you provide hooks into your API for customers, they may not be aware of that. So they may block your thread. Like, for example, if you are using some kind of a non-blocking IO like Netty or Node.js kind of processing, when you have one thread and event loop, if you have customer code that plugs into your stuff and blocks things, that can be problematic. But fortunately, I mean that there is a way to detect those problems. And after I completed the book, we are working on such a solution of DataStax, I remember. So like plugging the additional like analysis for detecting potential blocking code or deadlocks. That was quite interesting. So maybe I would extend this idea here.
Yes. And another thing, so you have a chapter on third-party libraries, and how when you adopt a third-party library, you essentially become responsible for supporting it within the context of your application, which with open source libraries in particular is obviously, it becomes even more complicated because I mean, obviously there's the licensing issue. You've got to make sure that the third-party library that you're taking a dependency on is fits with your open source license, whether that be like GPL or Apache or MIT. But also, and this is something that I've run into with my own sort of libraries and packages that I've created over the years. If you take a dependency on a library, say a logging library, then you're forcing anyone who takes a dependency on your library to take a dependency on that logging library as well. And so you then I found that people were kind of creating a logging abstraction within their library that the consumer could then hook up their logging instance to, whether that's, in .NET it's nlog and serilog and log4net and those sorts of things. And yeah, that's a constant battle of trying to avoid taking dependencies on libraries where possible, if there is a choice within that, like dependency injection, like logging, like it's one of these things that we're hoping to solve with open telemetry. That's so if I can say one thing I would like to see in a future edition of the book, a chapter on telemetry and the sort of choice between traces, metrics, and logs, which are the kind of three data types of open telemetry at the moment. I've been told not to call them pillars.
Yeah. Also in the context of like many services that are connecting and like trying to provide business value, many services connecting with each other and having a chain of commands. Logging can be tricky because you cannot correlate stuff, but tracing allows you to do that. I mean, there are even some people have really strict views on that, like they think that tracing is enough, right? So you don't need logging at all. In some places, if you're in your code, maybe that's the direction in which we are going. But I think it's all, as you said, it's a very new approach. I would say, like, tracing was always there, but using it at this scale
the ideal would be that we use tracing everywhere and we have it always on. So every sample, every span gets written to some kind of back-end store. But I know that there are people out there who are generating petabytes of
the cost
trace data.
Of it would be.
And so, sometimes logging is the more affordable approach. And you keep logs, logs you can keep around for years and years. Traces tend to be shorter lived. So, yeah.
But for the tracing, you can also I see an approach of sampling for normal scenarios, right? If everything is going smoothly in your application, you can sample 1 out of 10,000 events. And in case of any of the potential problems, you can try save the trace for it.
Yes.
But there is a big trade-off between costs and visibility, right, of your application.
Yes.
The two more topics that I would add right now is the first is multi-tenancy. So I think there is all the cloud products are trying to limit costs by writing your software to be multi-tenant. Like that data stacks Astra database that is Cassandra on cloud went into that direction. Also, the Dremio cloud solution is using multi-tenancy, and there is a lot of tricky things there, like how to isolate your customers that are using the same environment, how to propagate information about which customer executed what. The authorizations is hard. There is a lot of interest. I mean, it's the topic for the whole book, I think, the multi-tenancy and supporting it in the cloud solutions.
Yes, absolutely. So you have actually, you don't sort of have a chapter about microservices and microservice architecture specifically, but you do have a lot of things in there about distributed systems. And some of the sort of potential mistakes and trade-offs in distributed systems as well, which is very helpful. This is something, obviously, that 2 years ago when you were writing the book was sort of on the rise. It's become kind of the de facto way of building systems now. Nobody's starting with a monolith and separating it out. They're sort of upfront trying to identify microservices. And I think you've got a lot of useful information in there on things like distributed transactions and sort of delivery of messages between microservices and so forth.
I was trying to structure this book in 2 parts. The first one was more low level about actual code. And the second part was about distributed systems. And I tried to touch on most of these important things like consistency, atomicity, and those delivery semantics.
And there's a lot of useful information in there. And then there's your last chapter, which made me chuckle. Keeping up to date with trends versus cost of maintenance of your code. So in my Programming's Greatest Mistakes talk, which is it's one of those strange talks. It's kind of informative, but mainly entertaining. It's one of those ones that goes very well in the last slot at a conference. And I talk about a couple of my mistakes in there as well. And one of them is when I was working on migrating a desktop application from Gupta SQL Windows to .NET. Way back in 2004, I think I started on it. So I was building this application using Windows Forms, which was the desktop application framework. And then in 2005 or 6, sort of in the middle of this project, Microsoft released Windows Presentation Foundation, which was all new and shiny. And so my thought was, this is a brand new sort of project, and we've been supporting the last one for 20 years, and we're going to be supporting this one for the next 20 years. So I should switch to the newer framework. And then attempting to do that, quite frankly, almost killed me. And I ended up completely burning out, having to take an extended break from work. And so, yeah, that chapter definitely hit home for me. It's a very fine line that you have to walk, making sure that you don't have outdated things in your code base, but at the same time, you can't chase every single new thing that comes along.
Because you said that about the project that was already there to migrate to new stuff, but also it applies to like greenfield projects. So you shouldn't try to use all, the new stuff like event-driven microservices, using the GraphQL and so on, because maybe you don't need everything. And what you get complexity. Maybe you don't need to be on the actual edge, but a bit like maybe use something from a year ago, or that has proven on the production and has good documentation, a lot of good discussions on Stack Overflow or somewhere else. I'm in this chapter. I'm focusing on as I said before, dependency injection, also reactive programming that solves some specific problems, but it's complex, right? Also functional programming, using in the languages that are not fit for that, because functional programming and ideas are great, right? Immutability and so on. But sometimes you have languages that doesn't support it very well, and you need to kind of emulate that. And what you get is hybrid approach without the benefits of it, but with all the drawbacks that you may get. But there is a lot of examples. I think if as you mentioned, also this migrating to a new library that maybe break compatibility, right? I imagine if it was so hard to migrate. So there could be a list of tens of examples, I think. Yeah.
Okay. So yes, like I say, I've said it before. I very much enjoyed reading the book. It's very well written. I find it difficult personally to read badly written prose, but this it was very, very easy to read, and I enjoyed it, and it made a lot of sense. There's a lot of very good advice in there. There's a lot to think about, and like I say, I very much like the fact that it's not offering a magic bullet that can solve all problems. It is talking about how to think about these problems and what factors to consider when weighing these things up. So the book is Software Mistakes and Tradeoffs by Tomasz Lelek and John Skeet. It is available from all good booksellers. It's published by Manning, so you can also buy it as an ebook and live book and so forth through manning.com.
Even an audiobook.
Yeah. And audiobook. This one actually would work as an audiobook. So having sort of got this one out there, writing a book, I've written a short one myself, and it's a lot of work, and particularly at the end where you're working with editors and knocking it into shape and having the reviews done by other authors and so forth. So are you up for writing another one? Have you got any other books inside you? Or are you happy to let this one sit there for a while?
No, not yet. I think, as you said, it's a lot of work. And also I write it in a way that it should be up to date for many years, I hope. So for now, and maybe I will try. I'm collecting some ideas for the future one, but I don't think it will happen very soon.
Okay. So, and you've just started a family, so I'm guessing you're going to have a little bit less free time over the coming years. So
yes, that's a good advice. You can start writing a book before you starting.
Yes, yeah, absolutely. Okay, well, thank you very much for talking to me about this, and thank you for the book. It is, I recommend it to anybody who is building software. To be honest, it is applicable across all languages, all frameworks, all types of software. There really is something in there for everybody. So yeah, thank you.
Yes, thanks for the invite.
Thanks for listening to this episode of the GoTo podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.